Alright, so we mainly have three types of relationships in object-oriented programming. This is composition, aggregation, and association. And so we're going to be diving into aggregation in this video. So what is aggregation? Aggregation is a weak relationship. They do refer to it as has a relationship. In this particular example, where we have department aggregates an employee object, or we can say that a department aggregates many employee objects, hence being a one-to-many relationship. So your department is one class, one object. One object of department would be one object would aggregate many objects of employee. Let's understand this further. Let's understand the aggregation relationship. Yes, it is a weak relationship. However, these employee objects are independent of the department. So all these employee objects are created outside the department. Why outside the department? What do we mean by outside the department? Employee objects are created outside the department's init. So instructor, the initializer, or in other words the constructor, will not be creating employee objects. Employee objects will be created outside the department. So if your department object was to be deleted, then your employee objects would still remain. They are independent. However, if your department was to be created, your employee objects will not be created automatically, because employee objects are only created outside the department's constructor. And so the department here will be holding a reference to all employees in case of a one-to-many relationship. If it was a one-to-one relationship, well, then your department will hold reference to one single employee. And so how would it hold reference to all employees? This is done by a list for a one-to-many relationship. If it was one-to-one, then a single variable would be enough. Let's take this another example. We have a team that will be aggregating players. This is the one object that will be related to many. The team is going to hold reference to many player objects. And so if your team object was deleted, this doesn't mean your players will be deleted. Your players would still exist because they are independent of the team. Let's take this example where we have an object of a player called Cristiano Ronaldo. And so Cristiano Ronaldo is independent of his team, because if Real Madrid, the team Real Madrid, was suspended from the football league, well, then Cristiano Ronaldo will still remain. If the team was deleted, the player would still remain. And so in here, I'm not asking you to memorize this. However, I do urge you to understand this. The only way you can fully understand this is by understanding the code behind it. There is something special for a one-to-many relationship, particularly in the one class. So department is the one class that is aggregating many employees. Team is the one class aggregating many players. It will maintain a list of all the employee objects. So this is a list, has a list. Department, the one class, has the list. It has an add to list method. What do you mean add to list method? It is going to be appending an employee object into this list. It has another third method that will be removing an employee from a list. This is special for the one class. What if we had a one-to-one relationship? In a one-to-one relationship, then it will be maintaining a reference to the employee object only. It is going to be having a setter that will set an employee, and will be having a deleter that will maybe delete the employee. That is just for the one-to-one relationship. Now let's try converting the UML to Python code. This is not UML, this is just a rough abstract class diagram. UML is much more detailed, but let's go into the code. So we have class department. We're creating class department. This is the one. So it has an initializer. Within an initializer, there are no attributes and holds reference to employees as a list. That is done for the initializer. Now we have a method called added employee. This will be appending an employee object, so this employee object, into this list. And so let's add a comment to future programmers to to keep them warned that this is an employee object. This is just a comment. So self employees this list dot append employee. Let's have another method called remove an employee. So this remove employee will be again going to the self employee, will be taking an employee object. This is here an object of employee, and will be removing the employee from the list using this list remove function. Maybe we need to have a try except block that will make it safer. Let's create an employee class. Employee class will be your many. This will be many. So def init self id takes in an id, takes in a name, and takes in an age. Self.id, all caps of course, and then self name, and then self.age is equal to age. And we're done for this code implementation. Now we need to run this. So let's run this and create a department object. So let's create the department object is equal to department. Don't forget the parentheses. And then let's start by creating. Now there is something to notice, that as soon as your department has been created, your employees will not be created automatically. They're not going to be created automatically. That is aggregation actually. So your employees will be created outside the init. This is aggregation. So as in aggregation, your employee objects will be created outside because they are independent. That's how we make them independent. Let's create employee 2. So let's make it as Alice, and then his ID is 2. And then his age is maybe 26. And then now let's add an employee. So we have this method called add an employee. Now add employee 1 as an argument will then add an employee object to the list. Let's add employee 2, and employee 2 will be added to the department. Now if department was deleted, let's delete department, employee's object would still remain. And so this is here the whole big picture of the this is the big picture of the aggregation. I hope you found this helpful, and thank you.